Hello, my name is Humberto Doce, and today I'm going to be talking about DHCP in IPv4 and IPv6. So I want to start off with, what is DHCP? DHCP stands for Dynamic Host Configuration Protocol. DHCP is a service that can be used on any server, whether it be a Windows server or a Linux server. It is also used in many in-home and office routers. So what does a DHCP service do on a server? A DHCP service on a server automatically assigns IP addresses, subnet mask, default gateway, and a DNS server to a computer dynamically. How does DHCP work? Once the PC has been configured to automatically obtain an IP address from the DHCP server, the PC sends an IP request to the DHCP server. Then the DHCP server assigns the PC an IP from its pool. Now I'm going to be talking about DHCP v4. DHCP v4 has a 4-step process for a client to obtain a lease. Number 1, DHCP discover. The client uses layer 2 and 3 broadcast addresses to discover a DHCP server. Number 2, DHCP offer. DHCP v4 sends the binding DHCP offer message to the requesting as a unicast. Number 3, DHCP request. The client sends back a broadcast DHCP request in response to the server's offer. Number 4, DHCP acknowledgement or DHCP ACK. The server replies with a unicast DHCP ACK message. And that is the process a client has to go to obtain a lease when using DHCP v4. Here is a basic configuration of a DHCP v4 server. Number 1, excluding IPv4 addresses. IP DHCP excluded -address can exclude a single address or a range of addresses from being assigned to a client. Number 2, configuring a DHCP v4 pool. IP DHCP pool-name. This command creates a pool with a specific name and then puts the router in DHCP v4 configuration mode. Number 3, address pool assigned using network command. Number 4, default gateway assigned using default-router command. And that is a basic configuration of a DHCP server. Now, here's a basic configuration of a DHCP v4 router. Number 1, use the IP address DHCP command in interface configuration mode. Number 2, use help-address to allow the router to act as a relay and forward the broadcast message to the DHCP v4 server. This command will help the router forward the message to the DHCP server. As for the client side, when configuring a PC in DHCP v4, all you have to do is set wireless routers to receive IPv4 addressing information automatically. Now we're gonna jump into DHCP v6. Here are 2 ways to assign DHCP v6 to a client. Number 1, stateless address auto configuration or SLAAC, SLAAC. Number 2, dynamic host configuration. Now let me get into SLAAC operation. Number 1, the router must have IPv6 routing enabled, and the command would be IPv6 unicast-routing. Number 2, the PC would send an RS message to all the routers as a multicast address, requesting an RA. Number 3, a router would respond with an RA message that has the prefix and the prefix length of the network. Number 4, the PC would then use the information it received to create its IPv6 global unicast address. Then it would create its interface ID using EUI-64, or it would randomly generate it. Number 5, the PC would have to verify that the address is unique by sending a ICMP v6 neighbor solicitation. Now, configuring a router as a stateless DHCP server consists of 4 commands. Number 1, enable IPv6 routing using the command IPv6 unicast-routing. Number 2, configure a DHCP v6 pool using the command IPv6 DHCP pool-name. Number 3, configure pool parameters using the command DNS-server server address. Number 4, configure the DHCP v6 interface using the command IPv6 server pool-name. Now there's only 2 steps in configuring a router as a stateless DHCP v6 client. Number 1, IPv6 enabled on the interface using the command IPv6 enabled. Number 2, enable automatic configuration IPv6 addressing using the command IPv6 address autoconfig. And those are a few basic configurations of DHCP v6. Now I'm going to talk about the disadvantages and benefits that I found of DHCP. First, I want to talk about the disadvantages. Now, I wasn't able to find many. However, the one that caught my attention the most was that the DHCP server can be a single point of failure in a network if it is the only DHCP server configured. This is because if it's the only DHCP server configured, the whole network is running off of that single DHCP server. And if that server goes down, the whole company, the whole network goes down. Therefore, it would cause loss in business, loss in production, and even the loss of money, depending on the organization you're working for. However, that is a problem that can easily be fixed by having multiple servers up and running with the DHCP service. However, I found that there are more benefits brought by having DHCP. Number 1, it makes it easier to assign IP addresses because of its automation of IP distribution. Number 2, it eliminates the possibility of an IP address conflict. This happens when 2 PCs have the same IP address on the same network, which can be a big problem. But with DHCP, that is all solved. This is done because a DHCP server leases out IP addresses to the PCs, therefore also not allowing the DHCP server to run out of IP addresses from the scope. Lastly, the DHCP server has the ability to reserve IP addresses for specific PCs. For example, if you want to reserve a specific IP address for an admin or a CEO. As you can see, DHCP has a lot of benefits, and it can help with the distribution of IP addresses in a great way. As for my personal opinion, I really like the idea and the concept of DHCP. It is very fast, very efficient, and it's very helpful. Thank you for watching this video on DHCP. I hope you found it informative and useful. Thank you.